So we have discussed textual presentation of data and tabular presentation of data. So the third and the last one that we have is diagrammatical presentation of data. So we are going to represent data in a diagrammatical form. So even in diagram, there are mainly three kinds of diagrams that we use to represent data. So the first one is geometric diagram, the second one is frequency diagram, and arithmetic diagram. So first we are going to discuss in detail geometric diagram. So when we talk about geometric diagram, there are two diagrams that we have to discuss, that is bar diagram and pie diagram, that is coming under the geometric diagram. So in bar diagram, again there are three types of bar diagram, that is simple bar diagram, multiple bar diagram, component bar diagram. So we shall see in detail with the example of all these different types of diagram. So simple bar diagram. So in this simple bar diagram, it comprises of a group of equi-spaced and equi-wide rectangular bars for each class or category. So you will see, equi-spaced and equi-wide rectangular bars. You will see a rectangular bars represented for each class or category of the data. And again, height or length of the bar reach the magnitude of data. So it is according to the height and length of the bars that will represent the magnitude of the data. And the lower end of the bar touches the baseline, such that the height of a bar starts from the 0 unit. So bars of a bar diagram can be visually compared, by the relative height, and accordingly data are comprehended quickly. So looking at the height of the bar, we can easily comprehend the data that is given through this simple bar diagram. Where do we use this bar diagram? Bar diagrams are suitable both for, frequency type and also non-frequency type variables and attributes. But, bar diagrams are more convenient for non-frequency data, such as when we want to represent income expenditure profile, export imports over the years, etc. So for a discrete variable, we use this most of the time simple bar diagrams. So I'm going to show you the figure or the diagrammatical representation or example of a bar diagram. So this is the example of a simple bar diagram. So in this bar diagram, we are representing the literacy rates of major states of India. And looking at this bar diagram, we are able to comprehend that Kerala state has got the highest literacy rates among all the states of India. So figure 4.1 shows the bar diagram of male literacy rates of major states of India. So the next one is multiple bar diagram. So this multiple bar diagram is used for comparing two or more sets of data. For example, income and expenditure, import or exports, marks obtained in different classes. So in all these cases, we use this multiple bar diagram to compare between the two sets of data, or it may be two or more data sets. So this is the example of a multiple bar diagram, which is, measuring the female literacy rate of major states of India over two census years, that is census 2001 and census 2011. So we are measuring two components, or we are comparing two components or two set of data, that is data of census of 2001 and census of 2011 about the female literacy rates of major states of India. So as you can see from this, multiple bar diagram, they are comparing the literacy rate of female in the census in the year 2000 and 2001 and in the year 2011, and we can comprehend that the literacy rate of female has increased over the years from 2001 to 2011. So that is the example of a multiple bar diagram. Moving on to the next is the component bar diagram. So component bar diagram or charts, also called sub-diagram, are very useful. They are very useful in comparing the sizes of different component parts, and they are also for throwing light on the relationship among these integral parts. So example, expenditure pattern, sales proceeds from different products. So in all these cases we use this component bar diagram to represent the data. So this component bar diagram, they are usually shaded or colored suitably, and it shows the bar and its subdivisions into two or more components. So figure 4.3 is an example of a component bar diagram. So we are comparing two data set here, that is enrollment at primary level in a state of Bihar. So we are giving that or representing the data of enrollment of a primary level in a state of Bihar. So the shaded part is the indication of the percentage of people who are out of school, and the unshaded part is the enrollment category. So in this same data we are representing or comparing two data sets. So this is the multiple bar diagram of boys and girls giving the data of enrollment at primary level in the state of Bihar. So under geometric diagram we have explained bar diagram. So now we have come to explaining the pie diagram. So what is a pie diagram? Pie diagram is also a part of a component diagram because it is comparing or through charts or diagram that we are representing two data. But unlike bar diagram, here it is a circle. We are representing it in a circular manner whose area is proportionally divided among the component it represents. So the area of the circle is proportionally divided according to the data that is given. So here it is in circular, unlike the bar diagram. So pie diagram is also called pie chart. So the circle is divided into as many parts as there are components by drawing straight lines from the center to the circumference of the circle. So usually this pie diagram is not drawn with absolute values of the category, but what we do is the values of each category are first expressed as percentage of the total value of all the categories. We are expressing in a percentage value of the total value of all the categories and then present it in the circle or the pie chart. So this is an example of a pie diagram or a pie chart. So distribution, we are representing the distribution of Indian population by their working forces, whether it is marginal worker, main worker or non-worker. So by looking at this pie chart, we are able to understand that the non-workers are much more. 37 crore population are under non-workers, and then main workers are 36 crore, and then marginal workers are 12 crore. So the data are represented in a circular pie chart after expressing it in the form of a percentage usually. So this is an example of a pie diagram. So moving on to the next is we have to discuss the frequency diagram. We have discussed the first one, that is diagrammatical representation of data, and the second one that we have is frequency diagram, though we are representing the diagram in the frequency manner. So under this frequency there are again four types of diagram, that is histogram, frequency polygon, frequency curve, and then O give. So these are the these are mainly four, classification of frequency diagram. So we are going to discuss firstly the histogram. So what is a histogram? It is a two-dimensional diagram, two-dimensional diagram, and it is also a set of rectangles with base as their intervals between class boundaries along the x-axis, and the height and width areas, proportional to the class frequency. So we shall be making clear of this histogram by looking at the example. So this is the example of a histogram. So we are representing data in the form of histogram, which is part of frequency diagram. So from this table 4.9, we are representing these data in a histogram. So we can say that these bar diagrams and histograms, they are a bit similar, but they are, different. So as it is given here, if the class intervals are of equal height, so here it is 45, 49, 50, 54, the class are of, equal interval. So which they generally are, the area of the rectangles are proportional to the respective frequencies. So this is a case of a, equal class interval. And there are sometimes you will come across, data. However, in some type of data, here it is given, it is convenient at times necessary to use varying weight of class intervals. So in some cases, you may find convenient to use, interval which are of unequal weight, different class interval. Example, when you are trying to tabulate the dates by eighths, it will be very meaningful as well as useful to have very short age intervals like 0, 1, 2, because here we are taking 5 as class interval, and if you are to calculate this, for example, given here date by age at that, it would be, it would not be giving you a meaningful comprehension of the data. So example, like when you are tabulating dates by age at that, it is meaningful or advisable to have a very short age class interval, but most of the time their class interval is of equal weight. So when intervals are equal, that is when all rectangles they have their same base, area can conveniently be represented by the frequency that they have. So when they have a equal class interval, this frequency can be represented easily. So as I have said, a histogram, looks similar to a bar diagram, but there are more differences than similarities between the two. So the spacing and the height or the area of bars are all arbitrary. So it is taken arbitrary without any, method in bar diagram, but a single vertical line would have served the same purpose bar diagram. But in the case of histogram, no space is left between the two rectangles. You see, there is no space left between the two rectangles. But in a bar diagram, some space must be left between consecutive bars. So in bar diagram, space is given here, but not in this histogram. Again, the height in the histogram is as important as its height. So the height of this histogram is important as its height of the diagram. So we can have a bar diagram, for both discrete and continuous variables, but histogram is drawn only for a continuous variable. So that is the difference again. So histogram also gives value of mode of the frequency distribution graphically as shown in figure 4.5, and the x coordinate of the dotted vertical line given the mode. So with the help of this frequency, or we are able to find out the mode as given here, we can find out the mode of the data because of the histogram. So the mode for this histogram is 80.6.